Hello dear students. In the previous class we have already studied what is gravitational force of attraction and what is centripetal force and so on. And in today's class we are going to learn the remaining topics of the lesson gravitation. The first one, as we already studied in the previous class, that is what is gravitational force of attraction and how it is measured. That is, we stated one law there, that is universal law of gravitation, that is F is equal to G into m divided by d square, where G is called gravitational constant, m is mass of the earth, and small m is the mass of the object, and d is the distance between the earth and the object, and this is force exerted by the earth on that object. This we have already studied in the previous class. This is universal law of gravitation. As we already stated that the force exerted on any body by the earth is directly proportional to the product of the masses of the two objects and inversely proportional to the square of the distance between them, as we know already. Now, let us come to know how to find out the unit of this G here first. In order to separate G, just you keep G here and bring these two other factors this side. F into d square, if you bring this to this side, and if you bring this m and m the other side, this becomes m is equal to G. Means here G is equal to F into d square divided by m into m. Now, how to get the unit of this G? Here, force, as you know already, force can be measured in terms of Newton, that is N Newton. D is nothing but the length, that is distance. That length will be measured in meter, that is meter square, divided by, here mass of the object is always measured in kg, that is kg into kg, that is kg square. So this unit will be Newton meter square per kg square. This is the unit of G. And the value of G is already invented by a scientist by name Henry Cavendish. By using a sensitive balance, he has given the value of G as G is equal to 6.732 into 10 to the power minus 11. This is accepted universally. Okay, so this is just value of G. This is unit of G. When we express this, unit of G is Newton meter square per kg square, and its value is 6.732 into 10 to the power minus 11. Now, this unit, if you write here, this will be Newton meter square per kg square. This is the value of G. Now coming to the force exerted by the earth on the moon, that we need to calculate. How to calculate that? F is equal to, as you know already, G, the value of G is, it is taken as 6.7 rounded off one, rounding of the other two places, into 10 to the power minus 11 into mass of the earth is 6 into 10 to the power 24, and mass of the moon, small m is mass of the moon here. Okay, in this equation, that is mass of the earth is 6 into 10 to the power 24, and mass of the moon is 7.4 into 10 to the power 22 divided by distance between the moon and the earth is 3.84 into 10 to the power 8 meter, that is square. When we simplify this one, we get F is equal to 2.01 into 10 to the power 20 Newton. This is the force exerted. This is after simplification. It will be a little lengthy process. So just I have avoided, just directly have written the value. That is 2.01 into 10 to the power 20 Newton. This is the force exerted by the earth on the moon. Means that moon is being pulled towards the earth with that type of force. Means with the magnitude of this much force, that is 2.01 into 10 to the power 20 Newton. Now, Next, coming to importance of universal law of gravitation. What is the importance? Which is the force which is binding us towards the earth? We are bonded to the earth. That force is nothing but gravitational force that can be expressed just by following the universal law of gravitation. This is first one. Second one, motion of the moon around the earth. That can also be defined based on universal law of gravitation. Next, motion of all the planets around the sun. They too can be expressed in terms of universal law of gravitation. Just it is applicable for them also. Next, last one, due to sun and the moon, there will be tides on the earth. These tides are arising just because of sun and the moon. This can also be defined based on the universal law of gravitation. This is the just importance of the gravitational force, universal law of gravitation. Next, coming to free fall. What is free fall? When we throw any object upward, it reaches certain height and it returns back to the earth. When it returns back to the earth, there is no any other external force acting on that object except the gravitational force of the earth. Then, if any object is just falling towards the earth, only in the gravitational force of attraction alone, not any other external forces except gravitational force of attraction, then that object is said to be in free fall. Now, for example, if I say for a free fall example, if I give, if you are standing on the top of a building, if you throw any ball downward, it is not a free fall because you are throwing the ball just by exerting little force on the ball, right? But if you hold a ball standing on the top of the building, just if you leave the ball, then you are not exerting any force on the ball. It is falling towards the earth just because of the gravitational force of attraction of the earth. Only gravitational force alone is acting on that ball, then that ball is said to be in free fall, right? Even when we are holding something at a higher position, and if we leave the hand, we may jump down just leaving by hand, then we too experience the free fall. But if we jump out of something, then it may not be a free fall because we are exerting extra force on our body. So these are just examples for free fall. Next, coming to acceleration due to gravity. Then what is that acceleration due to gravity? Let us take an example here. When we throw any object upward, when it goes upward, it comes to it after reaching certain height, it comes to rest and it returns back to the earth. Okay. When it starts falling towards the earth, then its velocity increases. There is change in the velocity. Change in the velocity is nothing but acceleration. This acceleration is accounting for some kind of force. Without force, there is no acceleration, right? That force is nothing but a gravitational force of attraction. As we have already studied in case of Newton's second law of motion, that is, if any object is moving, just we can express that as F is equal to m into a. M into a. We can express this one. That is F into ma. Now, if the object is moving towards the earth, falling towards the earth, then this acceleration it is provided only just because of gravitational force of attraction. So this acceleration which is given to that object during free fall, what it is getting that force means acceleration. That acceleration it is nothing but due to just gravitational force of the earth there. So that is why this acceleration which is given to the object just by gravitational pull, that is called acceleration due to gravity or gravitational force of attraction on that falling object, we can say. This acceleration due to gravity, we can write this equation as F is equal to m into g, we can write, because this acceleration it can be just due to gravitational force of attraction or acceleration due to gravity. That is why it is denoted by g. F can be expressed as m into g now, right? And when any object is falling towards the earth, it is independent of its mass. Any object, if that object is hollow or solid, no matter, whether it is having higher mass or lower mass, it doesn't matter. Any object which is falling towards the earth from a certain height, it experiences the same kind of acceleration, that is g. What type of acceleration is given to that one ball made up of plastic, same type of acceleration will also be given to the one ball which is made up of steel, because here mass, they are independent of mass here. This acceleration due to gravity does not depend on mass of the falling objects. So what we can do is, just here F is equal to mg we can substitute. This is equation 2, we will call this as equation 1. Now value of g for terrestrial objects and celestial objects. Now to calculate, means what type of exertion is being exerted, force is being exerted on the objects which are falling towards the earth when they are on the earth, on the surface of the earth, or near the surface of the earth, or when the object is away from the earth. There are two cases. When the object is near the surface of the earth or on the surface of the earth, then it is called just terrestrial object we can say. When it is under some motion, that is influenced by, its motion is under the influence of only gravitational force of attraction. So what we can say is here, now let us compare equation 1 and 2, that is mg is equal to g into m divided by d square. Here m is nothing but mass of the object and capital M is the mass of the earth. This mass and this mass, they get cancelled. G is equal to g into m divided by d square. This remains. Now this is acceleration due to gravity, as we already studied. We need to calculate what is the value of this g. In order to calculate this, we have to consider the objects into two cases. In first case, we can consider the object when it is on the surface of the earth or near the surface of the earth. If you take near or on the surface of the earth, when the object is near or on the surface of the earth, what happens? This is the center of the earth and this is the object, say for example. Now the distance between the object and the center of the earth is, that is nothing but radius. This distance is nothing but radius. Okay. This radius of the earth, as we know already, it is r is equal to 6 into 10 to the power 6 meter it is. This is the radius of the earth. Now g is equal to this, by substituting the value 6.7 into 10 to the power minus 11 into mass of the earth 6 into 10 to the power 24 kg divided by d square, that is nothing but r. R means 6 into 10 to the power 6 bracket square. If you simplify this, after simplification we get the value of g as 9.8 meter per second square. This is the unit of acceleration. Unit of acceleration and unit of acceleration due to gravity, both are same, because when the objects are falling towards the earth, they are experiencing the acceleration only just because of gravitational force of attraction. So what type of acceleration they are getting? That is due to gravitational pull it is. So because of that, we are taking the unit of acceleration due to gravity, it may be, or acceleration, both are, that is meter per second square they are. Now g is equal to 9.8 meter per second square. This is the value of g and it is also called acceleration due to gravity, right? Now when the this is only objects which are on the earth, on the surface of the earth or near the surface of the earth, and we can call them as terrestrial objects, right? But one more case if you consider, you just imagine some of the objects which are away from the earth. That time we cannot take this distance as radius of the earth because they are away from the earth. You need to mention that exact distance, only then we can calculate that one. We cannot take in that case we cannot take the radius as the distance here. Only when the objects are on the earth, on the surface of the earth or near the surface of the earth, only we can consider, in that case r is equal to d, we can substitute. So this is just value of g. Now coming to motion of objects under the influence of gravitational force of attraction. As we have already studied, that is different equations of motion, that is phi is equal to u plus at, and next equation s is equal to ut plus half at square. Next one, phi square is equal to u square plus 2as. Now these equations are applicable for the objects which are moving on the earth, right? Means equations of motion these. But these objects, if they are influenced by the acceleration, just due to acceleration due to gravity, means only because of gravitational force of attraction, only that is creating that acceleration, then these equations can be modified as under the influence of, means we can say here, if an object is moving under the influence of gravitational force of attraction, then we can use these equations of motion in the same way, just by changing this a by g. That is, p can be expressed as u plus gt, we can do. Next, s will be just ut plus half gt square, and last one, v square is equal to u square plus 2gs. Now wherever a is there we can substitute g. This is how we can modify the equations of motion when the objects are moving only under the influence of gravitational force of attraction. Okay, till here we have studied. In the next class we will go ahead with the calculations which are based on these g, value of g, that is mass of the object or a force acting on the object, whatever it may be. We can go ahead with calculations in the next class. Okay, thank you.